Hi, this is for the 1.5. Okay, this is going to be for lesson 1, right? So second topic, second unit, this time with polynomials. It's going to be on page 115. All right, so we had talked about here for our learning goals, it's going to be all in the orange. So that's going to be, we're going to be multiplying polynomials. We're going to be talking about the closure, why it's closed under multiplication, and also recognize and use special products when multiplying binomials. All right, and so if you notice right here, Jason and Julie, they've multiplied. So this right here is the function, and they're simplifying the right-hand side. And we've done this before. In Algebra 1, you should have been introduced to this, this kind of thing. And one way that Jason has done it, if you take a look here, is that he used the area method. So let me just write down area method. I call it the box method. Area method is the same idea. Basically, what you're going to do is you're going to make an area like a rectangle out of it. So this one is a 1. This is a monomial, and we're multiplying by a binomial. So it's going to be literally like 1 to 2. And it's a little bit different than the way Jason did it because there's just so many boxes here. I don't really like that. That gets confusing for me. So if you're like me, so I'm just going to put the S here. So that's this S right here. And then the 100 minus 2S like that on the top. I usually put the one that's on the first one on the left and then the second parentheses on the top. Okay, you can do it whichever way, it doesn't really matter. Okay, and then just to clarify here, so this S right here goes with this S right here. And then this, let's make it this color. The inside the parentheses, the second part, that's this part right here. Okay, notice I put the minus 2S right here. It goes with the second one. All right, then all we would have to do is just find the area of this. Remember how to find the area of a rectangle? It's just length times width, right? So it's just S times 100, which is 100S. And then S times, in order to get this one, it's going to be, remember this length is the same thing as this one over here, which is S. So S times negative 2S is going to be negative 2S squared, right? And the way we'd write that answer is just going to be, I like to use the biggest exponent first. So that's going to be negative 2S squared plus 100S. And you might be like, well, how do you know it's a plus? And it's because it's positive, so we know that it's going to be a plus 100S. And that's it. So that would be the function. So this was, remember, A of S equals. All right. And so how is that similar to Julie's strategy? Remember this one? A lot of you guys, I've seen people do this on a test or on their own work, right? They just distribute. So you're distributing the S. Notice exactly the same thing as what Jason was doing here, except this one is more visual, okay? And then we're gonna skip over here to, okay, so the next page. So you just go to the next page, and this one we're just practicing the area model. So I would, again, for you guys, I would, if you were not here in class, make sure you practice that. If you already know the distributive way, like how Julie was doing, practice this way, just try it, okay? It's good to try different ways of looking at things. I really like this way because this is useful to, what was I gonna say? So that you don't forget distributing to one term, because some people do that sometimes, and especially when you get to like trinomials time as a binomial, that gets confusing. All right, so the answers are right here. I just box these guys. So you should get something like this. And another thing that we noticed in class, and maybe you guys see it here. Oh, this one's already boxed. And this guy right here. So if you notice right here, the ones that are highlighted into diagonals, those are like terms. So if the binomials that you're multiplying are the x is first and then a constant, it's going to look like this. So always these two guys are going to be the like terms. So that's why I highlighted them. All right, and so those are the ones you're combining. The ones that were not highlighted, they're not like terms because there's no other, if you look on here, there's literally no other x squares. All right, just if you were confused about how to set them up, I'm going to just show you the first one. Now let's do C, okay, because C could be kind of confusing, right? Because 2x squared, 2x plus 3 squared, what does that mean? And somebody in class had said, well, we know the square means that we're going to just multiply it by itself, so we can write it like this. 2x plus 3 times 2x plus 3. So I'm going to just write it underneath here. I'm going to show you how I would set it up. So I'm going to just draw a box like this. And this is 2 terms. So I'm going to make this have 2 terms. And this one has 2 terms. So it's a 2 by 2 if you're thinking about it like areas. So I'm going to write 2x plus 3. This top is going to be 2x plus 3, right? So 2x times 2x, that's going to be 4x squared, right? Remember, when it's x times x, the definition of x times x is x squared. Or maybe that's what the definition of x squared is, right? And then same thing here. So 2x times 3, right? That's going to give us this. So it's going to be like 6x, like this. And then 3 times 2x, that's again going to be 6x. And then 3 times 3, that's going to give us the 9. All right. And remember this, these in the diagonals, those are our like terms. Notice that they both have x's and no exponents. It's exactly the same, right? So that's how we know that they are like terms. So 6x plus 6x is going to be the 12x, and that's how we got that. And then we have the 4x squared. There's no other like terms, and then the plus 9, just like that. All right. So try those out. I would take a look at these answers. I would especially take a look at the D, just to make sure that you know how to do them. All right, we're going to go down here. We're going to scroll down. So now this one for the next page, this is page 117. We were just doing it Julie's way. So we're just going to use distributive property. Right, so this one is what we call the it's terrible. The distributive property, okay? So you're just doing an extensive distributing, right? And then so basically you're going to take the x plus 5 and you're going to distribute to x minus 2, right? And so if you notice right here for a, we do exactly that. So we're going to take the x of the 5x, multiply it with the first term of the second binomial. So 5x times 2x, which would be 10x squared, right? And then 5x plus 1, 5x times 1, sorry, is going to be 5x. And then on the, now I like to use the bottom. Some people still stay with the top, but it just gets confusing for me. So I just go to the bottom. So it's going to be -1 times 2x. It's going to be -2x. And then -1 times 1 is going to be -1. And then again, we're going to combine like terms. The 2 middle terms are the same. And again, if they're in this form, they'll always be the same, right? But you'll notice that pattern. 5x minus 2x is 3x. And so this would be your answer right here. Okay. And if you have not already, I would make sure that you try these out. I would pause right now. Don't look at the answers, and then try them out. Okay. And then one thing that, actually, I won't say it. So if you notice right here, and also on a test or anything like that from here on out, whether if I'm asking you to multiply 2 polynomials, whether you do it the distributive way or the box method way, which is still distributive, it's just a visual model. Either way you choose to do it, it's up to you. Just do it right, and then you're fine. Yeah, I don't care which way you use it. And so if we have, this is a common mistake. Okay, so Cheyenne, poor Cheyenne, she's trying to figure things out, right? And she's like, okay, well, x plus 4 squared, distribute the 2. So this must be, we're just going to distribute this. So this is going to be x squared plus 4 squared. So that's going to be x squared plus 16. Yay, no. Okay, so please remember, this is an exponent, and we can't do that. Remember, like somebody had said before, that the square means that it's just going to be x plus 4 times itself again. We do that 2 times because it says 2. If it said 3, we would do it 3 times. And erase all this because that's a big no-no. Don't keep that in your brain. Erase, delete it. Okay, so again, just like how we did before, we would just distribute it. We would get some x squared plus 4x plus 4x plus 16. So what were they missing? They were missing this whole middle term right here. So Cheyenne missed this. She got the first and last part right, but she totally missed out on that middle term there. That's why it's wrong, right? So just make sure that you're not the one who's making this kind of mistake. A lot of people do that. Remember, this is not the same as if it was 2 times x plus 4. This is completely different. This is not the same as x plus 4 squared. So I'm saying that's not the same. Not the same. Okay. When we're multiplying the 2 and the parentheses, they're multiplying, right? So that means we can distribute it. This one, it is to the power of 2, right? So that's not just distributing that. It doesn't work like that. Okay, especially because we have this plus there. All right, so these are not the same. Just make sure you remember that. And when it's talking about based on the definition of closure, our polynomial is closed under the operation of multiplication. So basically what it's saying, when we multiply 2 polynomials, and you'd be like, well, what are polynomials? I'll be like, remember, it's these guys right here. So these are 2 polynomials, a binomial and a binomial, right? When we multiply 2 binomials, right, 2 polynomials, what are we going to get as a result? Another polynomial, meaning you're not going to get exponents that are all of a sudden fractions or all of a sudden negative, or yeah, it's just not going to work like that. So you shouldn't see x's in the denominator, right? Like you can't magically have that. So any polynomial times another polynomial, I'm just going to say poly, is equal to another polynomial, whatever it is. Okay, it's like number times a number is going to give you a number. A number times a number, if that gives you a variable, you're in trouble. All right, we're going to go on to the next part right there. Okay, so this is, some of you guys might be wondering, is there a shortcut way of doing this? And I will say for the most part, no, there's no shortcut way. It's just long, okay? It's like, it's not hard, it's just long, okay? But there are a few little bit of shortcuts, okay? So if you notice, in the very few instances, but it does happen. So take a look at this, guys. Process. If you haven't done this right-hand side, take some time to do it. Pause, try and do it. Because if you just watch me do it, I get to learn more, but you're not going to learn as much as me because I'm the one who's doing it. Whoever's doing the math is learning. Oh, that's what I heard. Okay, so here, if you notice for this one, x minus 4 and x plus 4. Well, this kind of looks like Cheyenne's work. Like where's the middle term? So okay, let me just show you. I'll just use the box method because I like it. I wish I learned the box method way, but no, I didn't. I learned just the regular distributive way, which is fine. But so x times x is x squared. X times negative 4 is negative 4x. And negative, I should just go, x times 4 is 4x. This bottom one is negative 16. Why? Because negative 4 times 4. All right, and if you notice here, do you see what I see? Do you see what I see? I can't do it with that color, I'll just do it with this color. What happens to those guys? Yep, they cancel out. 4x minus 4x, this becomes 0. That's where it went. Oh, that's not what I want. So that's going to be x squared minus 16. I mean, if you really want to, like x squared plus 0x minus 0x minus 16, but why, right? So that is the middle term right there. It is 0x, which is just 0. All right, so yeah, it's not like we forgot. We didn't do Cheyenne's mistake. That wasn't it, right? Because remember, these are not exactly the same. These are different. There was no square there. So yes, you do end up with an x squared minus 16. And this is why people like Cheyenne get confused, okay? Because there are answers like this. It gets confusing, all right? So x squared minus 16, and notice the first ones for all the A, B, C's, and D's, right? And we always get that. These two binomials, they're multiplied together, and we get another binomial. All the other ones, we get trinomials. Weird, right? But yeah, all the middle terms cancel out. And if you notice right here, they look exactly the same, except one's a minus and one's a plus, okay? So that's what's going to give us. So only in these instances, if you want to look at it this way, so x minus 4, x plus 4, only for this, you could just multiply the first terms, so the x squares, and then this last terms minus 16x. Done. Shortcut. It only happens for those. If this is a 4 and that's a 2, you can't do that anymore. It's like, it doesn't work, okay? Only when they're exactly the same. And remember what we call, well, I can't say because we're going to call it something soon. All right, and then so when they're both exactly the same, so this technically, you could have seen this as x plus 4 squared. This is what it could have been, right, written as. Or in this one right here is x minus 4 squared, right? And what do you guys notice? It's exactly the same answer, except one's a plus and one's a minus. So basically, the shortcut way to do this is you take the 4 and multiply with the coefficient, which would be 4, and then double it. So that's going to be 8x, right? If that gets confusing, don't do that. It's unnecessary. You don't really need to know it. Just do it this way. That's what I would do. I always do it this way. Or I do that in my brain, actually, right? You do these long enough, you start doing them in your brain. That's when you know you've practiced enough or a lot. All right, so same thing with all of these guys. Okay, so notice that it's just, so if these are pluses, then this second term is going to be a plus. And if these are minuses, then the second term is going to be a minus. And the other thing is notice that they're all, oh no, did you guys see the mistake here? This class didn't catch it. That should have been a plus. What? Should have been a plus. Hopefully you were not in third period. Third period. Let me just get away with that. Don't do that. So these should all be pluses. Why? Because positive times positive is a positive. And negative times negative is still a positive, right? That's why they're all pluses. Okay, so now that we have that, they actually have names. So if you notice right here, the one that's called, so the one that was, remember the plus and the minus, and they looked exactly the same, right? Except for the one has a minus, one has a plus, and it doesn't matter which order they're in, right? That is called a difference of two squares, or we would say, for short, difference of squares. And you'll see this, you'll hear this a lot in your pre-calc class. You'll hear it in probably even calculus class, and you'll hear it here, right? Difference of squares. That's just difference of squares. All right, and remember where does difference come from? Remember, differences means that minus right here. We're talking about that minus, and it's not helpful that it looks exactly the same color. So that minus right there. And what does the squares come from? That's kind of a square from these two guys, because these are, what do we call them? A squared and B squared. Like, what do you mean A squared and B squared? So just like how we did before. So remember, if it was like x minus 2 times x minus 2, what would be my answer? We'll do this short. Oh, sorry, it's got to be a plus. One of them's got to be a plus. So remember, we just do the first guys, so x squared, and then the last two guys, so it'd be minus 2 squared. They're like, wait, isn't that 4? I'm like, yeah, but I'm just showing you a different way. So this is like your a squared, just like they're saying here, a squared minus, just like how they have it, and then 2 squared, which we know is 4, right? And but that's in that b squared form, right? So that's why we call it a difference of squares. Difference of squares. All right. And if you notice right here, the other type that we have, this has to do with the green ones right here. I try to keep the colors the same, right? Is these are perfect square trinomials, okay, because they make up a perfect square. Okay, what do we mean by that? All right, so we're saying that a plus b squared, right, is going to give us this a squared plus 2ab plus b squared. What does that mean? Let's try this one more time. I'm just going to show you. I didn't get a chance to show you guys in class. So this is a plus b. This is a plus b. So if this is a plus b and this is a plus b, what does that mean? It's exactly a square. It's the same dimensions, right? A plus b and a plus b. So that's why it's a square, right? Perfect square, right? And then so this would be what? A squared, a times b. Well, what's a times b? Just a times b, right? Just ab, right? What's b times a? Same thing. I'm just, they could say b times a, it could be ba, but I'm just going to write ab. We normally like to write in alphabetical order. Mathematicians are very like sequential, right? And then the last one was b times b, which was b squared. It's hip to b squared. Okay, so we're gonna just write those down. So remember, it's gonna be a squared. And remember what we said here. Yep, are these like terms? Yeah, they both have an a and a b, and they don't have any exponents for both of them. So it's exact same exponents. So good. How many of these do we got? We got 2. 2ab. So it's basically double that, plus b squared. That's how they're getting these things over here. It's not a mystery. It's quite the same thing. All right, so that's how they're getting them. Okay, so basically you can just multiply the A and the B and then just double it and you're going to get that middle term. Okay, and same thing with the B, you're just going to square that B and then you'll get the last term. All right, so let's see if that's true over here. We're going to try for this E right here because I notice here that this is very similar to this guy over here. Okay, so now, so I'm going to go, so this is my A is equal to 3x. My B is equal to 2, right? And there's, should I do negative? Because that means it'll just be the, actually, we'll do that. I'll say -2, keep it consistent. All right, so it's going to be 3. So remember, it's a squared plus 2ab plus b squared. Okay, so a squared, so it's going to be, that would be, let's just do it in our brain. Okay, that will be easier. So a squared, that's going to be 9x squared. Okay, plus 2ab. So we're going to multiply these two guys together. So 3x times -2 is -6x. Double that. It'll be -12x. And then we're going to do b squared. So that's going to be -2 squared, which is going to be plus 4. Let's see. Let's check to see if that's right. Hopefully that's right. If not, I need to rethink my career here. All right. 3x minus 2. No, I don't. You just make the mistake and you just admit it and you move on, right? Okay, let's see if that's true. So 3x times 3x is 9x squared. Oh, phew. So far, so good. 3x times -2, -6x. -2 times 3x, -6x. If I were to add those up, oh, good, -12x. We're doing good so far. -2 times -2 is +4. Woo, woo. All right, same thing. All right. So that's basically what it's talking about. If you don't want to memorize this, you don't have to memorize that. But honestly, if you do enough of these, you're going to figure out, your brain's going to figure out that pattern. Okay, you're like, oh, wait, there's a shortcut way. Because what do we always do? Try to find shortcuts. We're like, okay, there's got to be a better way. There's got to be a shortcut, right? Please make sure you note here that you could either rewrite it as x plus 8 times x plus 8, or just remember, just don't do what Cheyenne did. Okay, and if you don't remember what Cheyenne did, look a couple pages ago. Okay. And we could do the same thing here. So the x, so a is equal to x, b is equal to, what is it called? B is equal to 8, right? And then we're going to go, it's going to be x squared plus x times b, which is bx, times that by 2, which would be bx. 8x, I meant 8x, times that by 2, so 16x plus 64. Boom, just like that. And you can go ahead and try and see if that works. Okay, and this guy right here, what is this going to be? 9x squared plus 6x, 12x, plus 4. Oh, look, very similar. And then this guy right here, oh, this is difference of squares. If you notice, I can tell because it's exactly the same, but one is a minus and one is a plus. So it's not the same as these guys up here. So it's going to be just 9x squared. And then, so we're multiplying the front ones, and now we're going to multiply the last ones, minus 4. Because middle terms cancel out. Okay, and so putting this into practice, don't get confused. All right, so let's see. We're adding here. So this is x squared plus x squared, so I should have a 2x squared. So automatically, I'm going to look at, maybe it's this one, and then is -3 plus 2. Yep, it's going to be 1. All right, moving on to the next one. I suppose I should say like A right here, or D. We got that to be D. All right, this one's going to be x squared minus x squared. So I'm going to have no x squares. That's going to be 0. And then -3 minus a 2. So that would be -5. Oh, look, -5 right here. That is going to be our F. I can get it to look like an F. All right, and then here, x squared minus an x squared. We're going to have no more x squares. So all I'm going to have is just a number. So it looks, I'm thinking it's probably going to be -1 because that's the only one that with just a number. But hopefully that's right. So -3 minus a -2. This always messes people up. So -3, remember when we subtract, we go to the left, right? But then when it says minus a negative, right? Which means go the opposite way. So we're actually going to the right. How many? 2. 1, 2. So where do we end up? That's at -1. Right here. Yay. That's going to be A. And then next one, x squared plus x squared. So that's going to be 2x squared for sure. So it's maybe, probably E, because that's the only one with 2x squared. Right? And then if I go -3 minus 2, so that's definitely going to be, oh, hello. There we go. Yep, -5. Okay, so that is going to be our E. And again, so this is going to be negative x squared minus x squared. So that's going to be -2x squared. So it's going to be one of these two guys. I just don't know which one. So again, remember, distribute the negative with that -3. So it's -3 plus 2 is going to be -1. Shoom. Just like that. That's going to be B. Forgot to change my pencil. Okay, so so this one, negative x squared minus x squared is going to be -2x squared. And then this is going to be -3. Don't forget to distribute that. Minus 2 is going to be -5. There we go. So that's going to be C. Then we're going to go on to the next one. Now we're multiplying. So make sure you're multiplying. So this is going to be x. So it's going to be one of these guys over here. I saw the separated them out completely. I would have mixed them up a little bit more. But that's just me. If I look at the very end, that's going to be -6, right? So I know automatically it's going to be one of these two guys. This is my multiplication, if I'm matching tricks, right? And then remember, if I'm the middle terms are going to be -3x and 2, so it's going to be -1. Aha, right here. So it's going to be right here at -1. Yay, so that's going to be I. And then the next one is going to be this guy. Which one do you think it is? Hurry up, do it. See if it can beat me. Still going to be negative, but now when I'm adding these two guys up, 3 minus 2, that's going to be the 1. Okay. Like, Miss Lee, how come you can do it in your head? It's because I've done this so many times. All right, this is going to be +6. Remember, they should both be positive. So yep, it's this guy right here. So that plus and a plus, right? Because there's no room for any minuses, right? If you have 2 pluses, you're never going to get a negative. It's not going to happen, right? And if that happens to your bank account, you should change your banker. All right, and then here, negative times negative is going to be a positive for the +6, and it should be this one here. Honestly, you should have just multiplied those out, but I didn't want to do that. I just did it in my brain. Sorry. All right. Please feel free to check. I may have done something wrong, so make sure you check. All right. And your homework is going to be right here. So here, given these functions, so a of x, b of x, and c of x, and you're going to just make these new functions, right, like we did on Tuesday, and you're going to be adding polynomials together. Okay. And if for number 4, you are going to be practicing what we did today, which is multiplying. You could do it with the box method way, the area method way, or you could do it with distributive. Either one, doesn't matter, because it's the same thing, right? And if you want to give yourself a little bit of a stretch, try this one. It is optional, all right? Don't forget to do your homework reflection as well as the exit ticket. Just exit ticket doesn't affect your grade, but it's a good way to really just check to see, are you getting it? And because it'll tell you the answer right away. All right, have a good one, guys.